Hi everyone, welcome to Sets lecture. So in this lecture we're going to cover 3 different examples. So sets are a built-in Python class, just like a tuple, a list, or a dictionary. And sets are based on a branch of mathematics called set theory, which includes union, difference, and intersection. We'll see how these 3 work in this lecture. And lastly, sets can only have unique elements, so no repeats. Okay, let's take a look at the first example here. So here we have S1, which is a set, but we also have S2, which is actually a list. Let's take a look at the output for S1 first. Okay, so you can see that all the elements, in this case these integers, are all unique. But we have here, when we defined S1, we have 3 number 1s. Okay, so what I want to do is convert S2, which is a list, into a set. So what I'll do is use the Python built-in class sets and then convert S2 into a set like so. And you can see that we're only having the unique values here. Okay, great. So what I'd like to do also is look at some of the set functions or methods. So if I do S1 dots and hit tab, you can see the various methods of functions from add all the way down to update. So we're not going to cover all of them, just the main ones. Okay, so I want to use add. .add. Let's put in, say, 300. So we do S1. You can see 300 is added on. Alright, and if I try again, of course we only have just 1. So let's say I want to take a look at the union. So if I do union and I do S2, it combines all the unique numbers together from both S1 and S2. But what if I do difference? So if I do difference, before I run this, what it's basically asking is, what's the unique values in S1 that are not in S2? So in this case, it would be 1, 20, and 300. Right, 1, 20, and 300. Okay, great. Conversely, if I were to do the other way around, so we should have 1000, 50, and 40. Great, which we do. And lastly, let's do the intersection. So essentially that's what the values or elements are shared between both S1 and S2. So in this case, it should be 10 and 30. And I think that's it. Yep, just 10 and 30. Okay, great. So let's take a look at the second example. Right, so we have checking for a superset, subset, update, remove, pop, and discard. Okay, so we have here our 2 sets, S3 and S4. And what I'd like to do is just check which one is which when it comes to being a superset or a subset. So if I do S4.is and we'll do superset S3. So before I run this, it should be obvious that it's actually a superset because S4 has all the elements that S3 has. So this should be true, which it is. And let's say I do the opposite and I do is subset, we're going to get false, of course. However, if I change this round and do S3 and then S4, we get true because of course S3 is a subset of S4. Alright, so let's say I want to do, let's do an update, and what I can do here is just add in some more numbers. So I'll put in, let's say 400 and 500, and we take a look now, you can see that I've got these numbers here. And let's say I want to remove them. So remove, and let's say I want to remove, let's do 10. Okay, so you can see that's not there anymore. However, if I try again, that's because I'm running the same cell, but if I put that on another cell, you can see I get a key error. And that's because 10 is not in there anymore. So if I just comment that out, you can see 10 is not there, but if I try again, I get that error. So I'd recommend you avoid using remove and instead use discard, and you won't get an error. So in fact, what you can do is just hold the shift and then hit tab, and you'll see remove an element from a set if it is a member. If the element is not a member, do nothing. And that's the difference between the remove and the discard. So I'd encourage you to use the discard instead of the remove. So let's say we want to use the pop. So the pop is completely indiscriminate, and it will randomly remove a value from your sets. So if I just run this, so removed a value, if I try again, and so on. So it's entirely arbitrary. In fact, it will tell you again, if you just do a shift and tab, remove and return an arbitrary set element, and so on. Okay, so I wouldn't encourage you to use the pop because, again, it's very indiscriminate. Okay, so let's just run that again. Right, so let's take a look at our third and final example. So it's to do with the true or false. So we have S5 here, and we've got a mixture this time. Now if I run this, we're only going to see the booleans, the strings, and we'll see the floats, the two floats, and the integers, but we're not going to see any zeros. And we're not going to see any ones either. So you can see that they're not there. And the reason for that is because true is numerically equivalent to 1. Similarly, false is equivalent to 0. So that's why they don't have the zeros and ones in there. Alright, so I hope that's been insightful, and I will see you in the next lecture. Thanks.